Hello everybody and welcome to this new lesson in which we are going to practice a little bit on loops, on brute forces, and now a little bit of math. We are given a positive integer n and we have to return true if the number is prime or false otherwise. Let's remember the definition. A number is prime if it has no divisors other than 1 and the number itself. If we take a look on the first example, we have n equals 10. What are the divisors of 10? Well, of course, 1 is a divisor of 10. But we also have 2, a divisor of 10. We also have 5, which divides 10. And of course, the number itself, 10 divides 10. So we don't care about the first and the last divisors, but 2 and 5, because they are divisors, they are different than 1 and 10. This will give us the answer that 10 is not a prime number, so we return false. If we take a look on the second example, n equals 13. And indeed, the divisors of 13 are only 1, so 1 divides 13 and the number itself. If you try out each and every number between 2 and 12, you are going to see that the remainder of the division of 13 and that number is going to be different than 0. So 13 is a prime number and we return true. The solution of this problem simply lies in the definition. Let me write the definition again. N is a prime number if and only if there doesn't exist an integer d between 2 and n minus 1 such that d divides n. Now, to be honest, I don't really like this "there doesn't exist" because I don't have a loop or other programming equivalent to it. So if I'm able to restate the definition such that this becomes for each and every integer d, then maybe I can make a while or a for loop. And indeed I can. Let's formulate the definition. N is a prime number if and only if for each integer d in the range from 2 to n minus 1, n modulo d is different than 0. So the remainder of n divided by d is different than 0. This means, of course, that d is not divisible by n. And if it happens for each and every integer in this range, we know that only 1 and n are going to be the divisors of this number, so it is definitely a prime one. Now, as you can see, I found a way to actually tell the computer how to check if n is a prime number. The computer is going to try out each and every value between 2 and n minus 1, and because n could be large, there could be many values in this range, so I'll obviously not do it by hand. I'm going to use a loop for this. And the easiest way to do this is using a for loop because the instructions are pretty simple. Initially, d equals 2. D will always get increased by 1 in order to check all of the values in this range, and d should always be less than or equal to n minus 1. Then, the second stage is, of course, checking this, which can be done, of course, using an if statement. Awesome. Let's see how the code looks like. First of all, I'll show you the pseudocode because this is the universal language of every programmer. It doesn't matter if you code in Python, JavaScript, or C++. Pseudocode is so simple that everybody understands it. So, as you can see, I have my loop here, which is going to be a for loop. I'm going to show you a code in JavaScript in a minute, in which I try every value for d between 2 and n minus 1. Then I check if n modulo d equals 0. This means I've found a divisor in this range, so I can return false right away because I know that n is a prime number. There is no need in trying out other divisors, right? And if my loop finishes execution naturally, so the value of d became n, which is not in this range anymore, then I'm going to be here. And of course, if I reach this point, this means that I haven't exceeded the function, so I haven't executed this line of code, which means that I didn't find any divisor, so the number is prime and I can return true. Alright, this is how the for loop looks in JavaScript. It is also very similar to the one in C++. Basically, we use a variable d, which is defined inside the for loop. So this variable d is actually going to live only inside the for loop. If, for example, here, out of the for loop, you try to print the value d or use it, the computer won't recognize it. This variable d initially equals 2, it should always be less than n, and it is always incremented. Basically, always gets increased by 1. So you can imagine what this means. It means that on the first iteration of our for loop, d equals 2. Then we enter the for loop and execute what is here. And after we are finished, we go back and we do this, d++. So on the next iteration, d should be equal to 3, but only if 3 is less than n. If it is, we execute again, we enter this again d++, d becomes 4. If it is less than n, execute what's here, and so on and so forth. Until, at some point, let's say the value of d was n minus 2, right? We finished what was here. We enter again the for loop. We increment d. d becomes n minus 1. And as you can see, this will be our last iteration. Because n minus 1 is still less than n, we are going to execute what's here. But on the next iteration, when we first increment the d, so d becomes equal to n, and then we check if its value is less than n, we will get a false. So we will not execute what's here, but exit the for loop right away. I can also write this code using a while loop instead of the for loop, but it will be a little uglier. Let's see how it looks like. As we know, the main difference between the for and the while loops is that the for loop takes inside of it the initialization, or initializations, there could have been more variables here, the condition or conditions, there could have been more conditions here, and the transition. While the while loop takes only the condition inside of it. So what should I do is make all my initializations here, let d equals 2. Here I have only the condition. What needs to happen in order for this while loop to still continue its execution, and the transition is inside the while loop. And in this example, they behave the same. D initially equals 2. Let's suppose 2 is less than n. I check if this happens. If not, I increment d here. So d becomes 3. And then after incrementing, I check again in order to see if I will still continue the execution. This is exactly what we've done in the for loop, right? So let's see, this is true. Let's see, this doesn't happen. The next value of d is going to be 4, right? And so on and so forth until at some point d equals n. And this condition is not satisfied anymore, so we exit the while loop. We won't worry about the time complexity right now, but what you should know is that because this for loop and also this while loop basically tries out each and every value between 2 and n minus 1, the total number of operations or iterations they do is equal to the total number of distinct values in this range, which is n minus 2. So we need a total of n minus 2 iterations in the worst case to check if n is a prime number. And of course, the worst case is indeed when n is a prime number, because we are checking each and every integer and no one is actually a divisor of n. There is actually a faster way of doing this, and I just want to mention it here because it's really worth to know it. Well, if n is not a prime number, this means that n has at least one divisor d, right? So n can be written as the product of d crossed n divided by d, where again, because this d is a divisor of n divided by d is going to be an integer. We can always suppose that d is less than or equal to n divided by d. And if not, guess what? We can denote this integer as d, and then this one is of course going to be our n divided by d. So if n is not a prime number, we can always find a divisor d such that d is less than or equal to n divided by d, which means that n divided by d is greater than or equal to d. So this product will actually be greater than or equal to d crossed d, which is d squared. So n will be greater than or equal to d squared. In conclusion, n is not a prime number if and only if there exists some divisor d of n, such that also d squared is less than or equal to n, or in other words, d is less than or equal to the square root of n. Let's write this again. N is not prime if and only if there exists some integer d which is greater than 1 but less than or equal to the square root of n such that d divides n. Or in other words, n is prime if and only if for each integer d between 2 and the square root of n modulo d is different than 0. This means that instead of trying out each and every integer between 2 and n minus 1, we can limit our search to trying out each and every integer between 2 and the square root of n, right? For example, in C++, it is sqrt of n, and so I think it is in JavaScript. And also in this piece of code, we just have to check while d is less than or equal to the square root of n. And only by changing these lines of code, instead of making a total of n minus 2 iterations, we are going to make a total of sqrt of n minus 1 iterations, which for great values of n is going to be very significant. But again, don't worry too much about the time complexity, we will understand this in a different module. All I need you to do for now is really understand how the for and while loops work, because we are going to use them each and every time, also in brute force approaches, but also in optimal solutions. This is it, guys. I hope you enjoyed it, and I'll see you on the next one. Bye.